Okay, in this video we're going to be taking a look at perpendicular lines. We'll be looking at the definition of perpendicular lines and at a few theorems about perpendicular lines. So to start with, perpendicular lines. This is probably something that you're familiar with. It's this idea that we have two lines that are going to intersect to form a right angle or a 90-degree angle, right? And this here is a symbol for perpendicular. So anytime that you want to write perpendicular, you can just use that symbol. If you want to indicate that two lines are perpendicular, like I have down here at part A and down below, I can just put that symbol between the two lines' names, and that indicates that they're perpendicular. So that upside down capital T, it just means perpendicular. So first off, even though the definition says that two lines are going to intersect to form a right angle, we've talked before about the fact that if two lines intersect and they form one right angle, that we know that there's actually going to be more than one right angle formed by that intersection, right? So if I have these two lines intersecting, let's just call them we'll just call it line M and line N. If they intersect and they form this as a right angle, well, I know that there's going to be some other angles formed by those lines intersecting, right? I'll name them 1, 2, and 3 right here. If angle 1, or if this angle right here is a right angle, I know that angle 2 is going to be a right angle because it's a vertical angle with the one that I already have marked as a 90-degree angle. I also know that 1 and 2 have to add up to 180. They're going to be supplementary because they combine to make line M. So if angle 2 is 90, that means this is going to be, so if I have this as a 90-degree angle, this also has to be a 90-degree angle. And if angle 1 is 90, then angle 3 is going to be 90 because they're vertical angles. So what do I know about the other angles formed by the intersection of these two lines? I know that they are all right angles, right? And we've actually already talked about that. So the definition of perpendicular lines, what we have up here, we can use that in a couple of different ways when we're solving problems or perhaps doing a proof. One way we can use it is if we're told that two lines are perpendicular, like I have over here in this diagram. If I have line JK and line MN, and I'm told that they're perpendicular, then I would know that each one of these four angles, angles 1, 2, 3, and 4, they're all right angles, just like I kind of demonstrated up here above, right? Even though there might only be one of them marked as a right angle, I know that all four of them will be a right angle. I could also say, well, if I was given a diagram where two lines intersect and one of the angles formed by their intersection was a right angle, right? So if one of the numbered angles is a right angle, then that would tell me that those two lines are perpendicular. It would tell me that line JK is perpendicular to line MN. If I just knew that one of those angles was a 90-degree angle, then I would know that those two lines are perpendicular. So here's a couple theorems, or a few theorems that we need to know about perpendicular lines. The first one says if two lines are perpendicular. So to kind of understand these theorems, sometimes I like to draw out what the hypothesis says and then explain what the conclusion would be. So the hypothesis of this theorem is just that two lines are perpendicular. So I'll just quickly throw a couple lines on my screen here. So these two lines are perpendicular. I know that. I'll indicate that by putting a 90-degree box right there. The conclusion would be is that they are going to form congruent adjacent angles, right? So if I numbered this angle 1, this angle 2, and this angle 3, I could say, and let's just call this line J, and they'll call this one line K. I could say that if line J is perpendicular to line K, then according to theorem 2-4, I know that angle 1 is congruent to angle 2. I know that angle 2 is congruent to angle 3. And if I wanted to put like a 4 right there, I could say that angle 1 is congruent to angle 4, or I could say that angle 3 is congruent to angle 4. That's what theorem 2-4 would tell me, that if these two lines are perpendicular, I have a bunch of pairs of congruent adjacent angles in that picture. Now theorem 2-5 is the converse of theorem 2-4. it says that if two lines form congruent adjacent angles. So if I had two lines intersecting here, we'll call these two lines R and S. If they form congruent adjacent angles, so if this angle is congruent to that angle right there, then I know that the lines must be perpendicular. So in other words, if, we'll call that angle, since I've used 1, 2, 3, and 4 up here, I'll call that angle 5 and that angle 6. If angle 5 in that picture is congruent to angle 6, then it's guaranteed that line R is perpendicular to line S. And lastly, theorem 2-6, we don't use it quite as much, but it says that if the exterior sides of two adjacent acute angles are perpendicular. So let's just sketch that out. We have a couple adjacent acute angles, right? So I'll put some points on here. We'll call it we'll call this point A. This can be point B, point C, and point D. If segment AB is perpendicular to segment AD, then what I know is that the angle ABC, then the measure of angle BAC, I said ABC, I should have said BAC, plus the measure of angle CAD must come out to equal 90, which is to say that the angles will be complementary. So let me just walk through that one more time, because I think I might have gotten a little bit lost in what I was trying to diagram here. What theorem 2-6 says is if these two, if side AB and side AD of these adjacent acute angles, if they are perpendicular, then it means that these two angles, BAC right here and CAD right there, they're going to add up to 90. I don't know if they're the same. They might be the same. They might be two 45-degree angles, or they might be like a 50-degree angle and a 40-degree angle. What I definitely know is that they're going to add up to 90. They're going to be complementary, right? And there's a quick, easy proof that we can do for that. Maybe we'll save it for another time, but it's pretty easy to prove that this theorem has to be true based on the picture that I kind of started with. So there are three theorems about perpendicular lines. Now let's take a look at what kind of conclusions we might be able to draw from those theorems and from the definition of perpendicular lines. I have a diagram here where I have a couple lines that are perpendicular, right? Line AB, right there, is going to be perpendicular to line CD right there. So my green line and my pink line are perpendicular. Does that mean that angle AB is that segment AB would be perpendicular to segment EF? Does that be true based on what I know to be true in this picture? Well, actually, I can guarantee that that has to be false. Well, how do I know it has to be false? Well, I know that this is a 90-degree angle right here because the green line and the pink line are perpendicular. I also know that this angle right here has some measure. And if the green line were definitely perpendicular, then angle AGF would have to be a 90-degree angle. But it's clearly not a 90-degree angle. It's going to be something more than 90, because in order to create AGF, I have to add the measure of angle AGD plus the measure of angle DGF. So that's going to be 90 plus something, right? So that can definitely not equal 90. So that means that this statement is definitely false. How about statement B? Can I guarantee that angle CGB is a 90-degree angle? Is that a right angle? Well, yes it is, right? Because if this is a right angle, or if these two segments are perpendicular, then I know that all the angles formed by the line segments, all of those angles are going to be a 90-degree angle. So I know that angle CGB is a right angle. I can say that that is true. Statement C says angle CGA is a right angle. Yep, that's going to be true. That's a 90-degree angle there. Statement D says that the measure of angle DGB is 90. Yep, that's going to be true. So all of these angles I know are going to be 90 because these two lines are perpendicular. Do I know that angle EGC EG angle complements? Yes, I know that that's definitely true because together they form this right angle, angle CGA. Do I know that angle DGF is complementary to angle DGA? Is angle DGF complementary to angle DGA? Will they add up to 90? I know that that's definitely false. I've kind of already talked about this, right? DGA by itself is 90, so I can't add anything to it and still have a 90-degree angle. So if I'm trying to say that these are complementary, it means that they add up to 90, but this one's 90 by itself, so that's false. How about angle EGA and DGF? Are those complementary? Aha, so this one's kind of a tricky one, right? Is angle EGA, is it complementary to angle DGF? Well, I know that the measure of angle EGC plus the measure of angle EGA, I know that's going to be 90 based on what I've said here in statement E, all right? That means that this has to be true. I also know that the measure of angle EGC is the same as the measure of angle DGF because they are vertical angles. So they're going to be congruent to each other. They're going to have the same measure. So look at what I can do. I can take this EGC, take it out, and put the DGF in its place because EGC and DGF have the same measure. So therefore, the measure of angle DGF plus the measure of angle EGA must equal 90. It's just this statement with EGC taken out and DGF put in. And so if DGF and EGA add up to 90, it means that they are definitely complementary. So that's a true statement. All right, there's one last thing on your note sheet. There's these 5 statements where you are going to use always, sometimes, or never to complete each statement. I'm actually going to leave those up to you. I want you to try and answer those, and then we will probably talk about those when we get back to class. All right, so everyone have a good night, and I'll see you in class.